Hello, in this video I'm going to be doing an example of a limiting reactant problem, and this is right from our s'more activity that we did, or will be doing. It says assume that you were to mix 100 grams of both N2 and H2. How many grams of NH3 would be produced? So, in order to do this, we need to first find our limiting reactant. Normally when we do stoichiometry, we just write down our given and convert to moles and then do our mole-mole ratio to predict product. However, in this case we have two givens. We've got 100 grams of N2 and 100 grams of H2. There's more than one way to solve this. I'll solve it first one way and then we'll go on to another way. And you can pick whichever way you feel most comfortable with. So first thing you do is write down 100 grams of N2 and 100 grams of H2. And you're just going to do the basic 5 steps of stoichiometry like you've done, only you're going to do it for 2 reactants. So we go on. First step, balance equation. Second step, write the given. Third step, convert to moles. So for N2, we put moles on top and grams of N2 on the bottom. The atomic mass of nitrogen is 14. Times it by 2 and you get 28. And I get that from the periodic table, the atomic masses. So 100 times 1 divided by 28, no way to solve that unless you come prepared with your calculator. So we got 100, and we're dividing it by 28. That gives you 3.57 moles of N2. We're then going to do the same thing with H2, multiply it by 1 mole of H2. And we're going to convert this guy by dividing it by grams of H2. Atomic mass of hydrogen is 1, but there's 2 of them, so it's 2 grams. 100 divided by 2 is 50 moles of H2. Alright, moving on. Step 4 is use your mole-to-mole ratio. Mole-to-mole ratio. And we want to find our product, so I'm going to do this for both of them. We got 2 moles of NH3 divided by 1 mole of N2. 2 over 1. And that's going to give me 3.57 times 2, which is 7.14 moles of NH3. Moving on to the second one, and now I want to predict how much product of NH3 is going to be produced if I have 50 moles of H2. So I'm going to put, again, 2 moles of NH3, that comes from my balance equation, the 2, over, in this case, 3 moles of H2. 3 moles of H2. 50 times 2 divided by 3. 33.3. Alright, so what I'm saying is if I have 100 grams of H2, I should be able to produce 33.3 moles of NH3, providing I have unlimited N2. But if I have 100 grams of N2 and unlimited amount of H2, I should be able to produce 7.14 moles of NH3. How do I know which reactant is my limiting? Is it my N2 or my H2? The one that produces the least amount of product would be considered my limiting reactant. It looks like N2 produces 7.14 moles of NH3, which is definitely the least amount of product, significantly less than 33.3. So N2 is my limiting reactant because it produces the least amount of product. Alright, well, what do we want to do it a different way? Maybe you don't like that way. I'm going to show you another way that's a little quicker, although it's a little more confusing. So if you don't like it, it's alright. If you do, great. You get to pick the way that fits you the best. Alright, so what we got is 100 grams of N2 and 100 grams of H2. You do the same thing. You convert it to moles and convert the other guy to moles. I'm going to rewrite this right here. We got 3.57 moles of N2, and we have 50 moles of H2. What I'm then going to do is designate a reactant 1 and designate a reactant 2. I'm just going to say this H2 is my reactant 1, and N2 is my reactant 2. Alright, so my reactant 1 I'm going to take and I'm going to compare it with my reactant 2. Moles of N2 over moles of H2. Looking at it, I've got 1 N2 for every 3 H2, so it's 1 over 3. So I'm going to do 50 times 1 divided by 3. 50 times 1 divided by 3. 16.66. And this is how much I need. I need 16.66 moles of N2 in order for H2 to be my limiting reactant. I'm then going to go back to how many moles of N2 I actually have. I've got 3.57 moles of N2, but I need 16.66 moles of N2 in order for H2 to be my limiting. I certainly don't have enough. Therefore, N2 would have to be my limiting reactant. And that's just another way of finding limiting reactant. Basically, the equation is reactant 1 times moles of reactant 2 over moles of reactant 1 equals needed. So moles of reactant 1 times moles of reactant 2 divided by moles of reactant 1 equals moles needed. And this comes from your balanced equation. Alright, and that is how you solve a limiting reactant problem. But if we want to go back and answer the question, it says how many grams of excess, how many moles of excess reactant would be left over after the reaction. We're going to get that next in a different video, so the video is not too long. Alright, thank you and good night.